So now we're not putting the first marble back. Okay? Well, then what? Well, okay, if the first marble turned out to be red, right? Since we're not putting it back, there's one less red marble there, right? And there's one less marble in the bag. Before there was 23, now there's 22, and there's only 9 red marbles. So in this case, right, the probability of event B that the second marble is red, that's 9 out of 22. Again, that's because we did not put the first marble back. And this is assuming it was red. But even if it wasn't red, things are going to be different. If it's not red, a red marble, there are 10 red marbles, yeah, but there's still one less marble, though. So the second marble in this case, if the first one was not red, the second marble was blue or black. So there's one less marble in there, it's 22. So the probability of event B in this case is 10 out of 22. What's the bottom line? The probability of event B does depend if event A occurred or not, right? If event A occurred, this is the probability of event B. If event A did not occur, this is the probability. In other words, whether or not event A occurred, that will affect the probability of the second event. These events are not independent. So these events are not independent. Notice also we didn't have to list the sample space. I mean, in the first one here, it wasn't that bad. There weren't many elements, right? There were not many elements. Okay? But here, there'd be a lot more elements, actually. I think there'd be 23 times 22, which is not terrible, but it's a pretty big number. We didn't have to list the sample space, which is nice. Thank goodness. Totally crazy. So this is another example that's similar to it. Let me see if I can get through it. Here, we're assuming that we're rolling a six-sided die, okay? But we're rolling it twice. We're rolling the six-sided die twice. Okay, so let's A be the event. So basically, we're rolling the die, noting the number, picking it up, and rolling it again. So we're saying A is the event that we roll a 5 first. B is the event we roll a 3 on the second toss. Well, these are going to be independent. Right? How do we know that? Because, you know, you roll the first number, you know what it is, but you're rolling the same exact die again. You know, the probabilities are still going to be the same. I mean, yeah, you could list the sample spaces I have here. Of course, that's going to be 36 members in that sample space. That's not terrible. I think the book lists it, but I'm not going to do that. So, you know, there's way too many elements in there. Okay. Okay, so that's another example. And this turned out to be the probability. Now, if you have two events that are independent, okay, that does help us calculate the probability of both occurring. In other words, if two events are independent, this is how we get the probability of both occurring. So if you want the probability of events A and B occurring, that's equal to the product of their probabilities. That's what this is telling us. That's if they're independent. If they're not independent, then you have to do something else. And that actually we'll see probably next time. I don't want to do too much more than this. So this is what happens if the events are independent. What I'm going to do, though, is I'm going to start from here next time. I want to look at my. I keep thinking these probabilities are wrong, but I'll look into that and let you guys know. I think it's a good time. I think it's a good place to stop here. Basically, what I'll do here is, we'll start from here next time. Let me stop here. Okay, let me stop recording.